Geometry, Chapter 3, Circles, Module 3. In this video, we will be studying about arcs, properties of arc, and the central angle. Let us recall what we have studied in our previous video. The first point, the point of contact of the touching circles lies on the line joining their centers. This is same as the touching circles theorem. That is, if the circle touch internally or externally, then the point of contact lies on the point joining their center. The second point, if the circles touch each other externally, distance between their center is equal to the sum of their radii. That is, if the two circles touch each other externally, then the distance between their center will be r1 plus r2. R1 is the radius of the first circle and R2 is the radius of the second circle. Third, the distance between the centers of the circle touching internally is equal to the difference of their radii. So if you have two circles that touch each other internally, then the distance between their centers will be R1 minus R2, where R1 is the radius of the first circle and R2 is the radius of the second circle. Arc of a circle. Let us understand the definition of arc of a circle. We know that a secant divides a circle in two parts. In this case, the secant AB is dividing my circle into two parts, the upper part and a lower part. The part which is bigger than the semicircle, or the arc that is bigger than the semicircle, is called a major arc. In this case, it is the major arc is arc AYB. The arc which is smaller than the semicircle is called as a minor arc. In this case, the minor arc is arc AXB. Note any one of these two parts and the common point of the circle and the secant constitute an arc of the circle. The point of intersection of the circle and the secants are called as the endpoints of the arc. So in this case, the end point of the major arc, arc AYB, is AB. Similarly, we can say that the endpoints of the minor arc AXB is A and B. Central angle. When the vertex of an angle is the center of a circle, it is called a central angle. In the figure, O is the center of a circle and angle AOB is a central angle. Also, note that AQB will be the major arc and APB will be the minor arc. Measure of an arc. To compare two arcs, we need to know their measures. Measure of an arc is defined as follows. Measure of a minor arc is equal to the measure of its corresponding central angle. In the figure, measure of central angle AOB is theta. Corresponding to the central angle is the arc APB. So, a measure arc APB will be equal to the measure of its corresponding central angle. So in this case, the measure of central angle AOB is theta. Therefore, measure angle APB must also be theta. So, measure angle AOB is equal to theta. Hence, corresponding to the central angle is the arc APB. Hence, measure arc APB will also be theta. Hence, from here we can conclude that the measure of the arc is equal to the measure of its corresponding central angle. Second property, measure of major arc will be equal to 360 degree minus measure of the corresponding minor arc. In the figure, measure of the major arc AQB will be equal to 360 degree that is the measure of the entire circle, which is 360. So therefore 360 degree minus the measure of the minor arc APB. Now in this case, if the measure of the minor arc APB is theta, we know that by central angle, the measure of the central angle is equal to the measure of the corresponding arc. So in this case, the central angle, angle AOB is theta, corresponding to the central angle is the arc APB. Hence, measure of arc APB will also be theta. So to find the measure of the major arc, we do 360 degree minus the measure of the minor arc. So it will be 360 minus the theta. For example, if measure of arc APB is 40 degree, that is measure of the minor arc is 40 degree, then measure of the major arc AQB from the figure, if measure of the minor arc APB is 40 degree, then measure of the major arc AQB will be 360 degree minus measure of the minor arc APB. So measure of the minor arc is 40 degree, which is substitute here 40. So 360 degree minus 40 degree will be 320 degree. Therefore, measure of the angle AOB will also be 40 degree because it is the central angle. Corresponding to the central angle is the minor arc APB, which is also 40 degree. And measure of the minor arc by doing the subtraction, measure of the major arc by doing the subtraction, we get arc AQB will be 320 degree. Third property, measure of a semicircular arc is 180 degree. In this circle, AB is the diameter of the circle and ACB and AYB are both semicircular arc. We know that measure of a semicircle is 180 degree. Hence, measure of a semicircular arc will also be 180 degree. Therefore, measure arc ACB is 180 degree. Similarly, measure arc AYB is 180 degree. The fourth property, we know this, that the measure of a complete circle is 360 degree. So if measure of the complete circle is 360 degree, since semicircle is half of a circle, so measure of the semicircular arc will be 180 degree. The next topic is congruence of arcs. The necessary condition for two arcs to be congruent is two arcs are congruent if their measures and radii are equal. So we can say that two arcs are congruent if the radius and their measures are equal. In the following figure, we can see circle with center C has a radius of 5 and circle with center A has a radius 5. Now the arc DF measure is 70 degree. So measure arc DF is 70 degree. Also measure arc BE is 70 degree. Therefore, both these arc DF will be congruent to arc BE. Next, we'll see the property of sum of measures of arcs. In the figure, the point A, B, C, D, and E are concyclic. Concyclic means all these points A, B, C, D, and E lie on the same circle. With these points, many arcs are formed. There is one and only one common point C to arc ABC and arc CDE. If we see arc ABC, arc CDE, C is a common point in both the arcs. So, measure of arc ACE is the sum of measures of arc ABC and CDE. That means measure arc ABC plus measure arc CDE is equal to measure arc ACE. So in case in two arcs, if you have one point common, we can use the property of some measure of arc. Theorem. We'll see a theorem. The statement of the theorem is the chords corresponding to congruent arcs of a circle or congruent circles are congruent. Let us understand the statement. It is given that in a circle with center B, arc ABC is congruent to arc DQE. We have to prove that chord AC is congruent to chord DE. The theorem states that the chords which are corresponding to congruent arcs of a circle are congruent. It is given that if the arc APC is congruent to arc DQE, then their corresponding chords, that is, chord corresponding to arc APC is AC, and the chord corresponding to arc DQE is DE. Since these two arcs are equal, the chord AC and DE should also be equal. So it is that is given to us in the question. In the statement of the theorem, in the circle with center B, arc APC is congruent to arc DQE, and we have to prove that chord AC is congruent to chord DE. Let us understand the proof. In triangle ABC and triangle DBE, ABC and DBE, side AB is congruent to side DB as they are the radius of the same circle. Angle ABC is congruent to angle DBE as measure of congruent arcs. Since the arc APC is congruent to arc DQE, their corresponding central angles will also be congruent. So for arc APC, the corresponding central angle is angle ABC, and for arc DQE, the corresponding central angle is angle DBC. So since the arcs are congruent, the central angles will also be congruent. Therefore, angle ABC is congruent to angle DBE. Side BC will be congruent to side BD. The same reason as they are the radius of the same circle. Therefore, triangle ABC will be congruent to triangle DBE by SAS test of congruency. Since these two triangles are congruent, AC, that is chord AC, will be congruent to chord DE, that is congruent sides of congruent triangle. The next theorem is a converse of the previous theorem. It states that corresponding arcs of congruent chords of a circle or congruent circles are congruent. Let us understand the statement. Given O is the center of the circle and chord PQ is congruent to chord RS, we have to prove that arc PMQ is congruent to arc RNS. So the theorem states that if the chords of the circle, that is chord PQ and chord RS, are congruent, then the arc corresponding to these chords will also be congruent. So the same thing is given. O is the center of the circle, chord PQ is congruent to chord RS, and we have to prove that arc PMQ is congruent to arc RNS. Note one thing, that the arc corresponding to chord PQ is PNQ, and the arc corresponding to chord RS is arc RNS. Let us start with the proof. In triangle POQ and triangle ROS, OP is equal to OQ and OR is equal to OS. The reason being they are the radius of the same circle. Chord PQ is equal to chord SR. This is given to us. Therefore, triangle POQ will be congruent to triangle ROS by SSS test of congruency. Since we have proved three sides of the triangle are equal, therefore triangle POQ will be congruent to triangle ROS by SSS test of congruency. Therefore, angle POQ is equal to angle SOR, as congruent triangles have congruent angles. So these two angles will be equal. Now the arc corresponding to the angle POQ, is a central angle, and the arc corresponding to the central angle POQ is PNQ. And the arc corresponding to the central angle SOR is arc RNS. Since the angles are equal, the corresponding arcs will also be equal. Therefore, measure arc PNQ is equal to measure arc RNS. Arc PNQ is the arc corresponding to angle POQ, and arc RNS is the arc corresponding to angle SOR. So, since angle POQ is equal to angle SOR, arc PMQ will be equal to arc RNS. Let us revise. First, the arc bigger than the semicircle is called as a major arc. The arc smaller than the semicircle is called as a minor arc. An angle whose vertex is the center of a circle is called a central angle. Fourth, definition of measure of an arc. The measure of a minor arc is a measure of its corresponding central angle. That means the measure of the central angle is same as the measure of its corresponding minor arc. To find the measure of the major arc, the formula we use is 360 degree minus measure of its corresponding minor arc. So if you know the measure of the minor arc, you do 360 minus the measure of its minor arc to find out the measure of the major arc. Next, measure of a semicircle is 180 degree. The fifth point, when two arcs of the same radius and the same measure, they are congruent. So for two arcs to be congruent, they should have the same measure and the same radius. When only one point C is common to arc ABC and arc CDE of the same circle, then we can use the property sum measure, that is measure arc ABC plus measure arc CDE is equal to measure arc ACE. So when two arcs have one point in common, then we can use this property. Note one thing, that when the two arcs have more than one point common, we cannot use this property. So the arc should have only one point in common to use this property.